Farahania from University of Porto. Basically, this work is a little bit far away from the topic of pickup. But however, it's about the rise of passive safety technological solutions for the transit buses. It's so I start with some introduction first, and it is based on the R66 standard regulation by the European Community for the transit buses. So we have loading condition, we have safety region definition, and the internal energy calculation. Therefore, we should define the model, general view of the experimental test. One of our main concerns here is about the safety region, and so this work is the link between the University and Industrial Partner, which is manufacturing the transit buses in Porto, and we received a geometry from them, started to make the experimental test and the numerical analysis, and we got the results. And you should see that if this kind of geometry under certain type of loading condition is going to meet the R66 standard regulation, or we should propose a new geometry. So in this case, it didn't pass, so we proposed our new geometry, and again, define the model and numerical results. So it is about so each passenger bus, which is 14.1 meter long, has some segments from the beginning of the bus to the rear. In this study, only one segment was considered, and as I mentioned before, it's about rollover test. It means that then in any situation, if a bus faces a rollover, what happens to the safety of the passenger and also to the structural response of the bus. In order to deal with this problem, the first idea came from the finite method analysis, which is simulated in Abacus, and also check the output with the R66 standard. The main concerns here are the safety region and also the internal energy that the structure is going to disappear regarding the loading condition. Just a brief introduction on the loading condition. So if you see the bus from the front, we have the loading condition defined by R66 with an angle to the roof, and there are some parameters that needed to be defined based on some geometrical characterization of the bus. And also here there is a safety region, we call it residual space, that needs to be included in the geometry. Basically, this is the passenger space, and there are some criteria needs to be met in the numerical analysis and also in the experimental test. These two graphs have been proposed by the R66 regarding the energy of the bus section. It should be equal to or greater than the minimum energy, and this is the total energy formulation. So the minimum at the end, according to the bus mass, the total mass of the vehicle, which is around 15.6 tons. So the section mass is 1.76 tons. So delta H, and at the end we should arrive at this. The energy of the structure should be equal to this or greater than this. Otherwise, the structure fails. And first, we started with the experimental test in our facility in the University of Porto. We brought this segment from the company, and we put it here in our facility, including the residual space, as I mentioned before here. And we pull the structure from the door side. So here is the door side, here is the window side. And we pull based on this kind of mechanism just to apply the loading condition in accordance with the standard. And the structure was the initial structure that is in function right now in all the city buses in Porto is based on steel in chassis, and the rest of the structure is in aluminum. So in general, both materials were participated in the nonlinear behavior. And we used the dynamic explicit analysis considering mass scaling, and the total mass of this segment was 506 kilogram. And regarding the safety criteria, on these pillars in the door side, we're supposed to monitor the displacement on the three different positions, and these 3 points should not have the displacement greater than the one that the regulation proposed. And this is the results. So this is the results of the force displacement. The red one is the experimental result, and the blue one is the numerical result. So this drop is because of I have seen this by eyes there that some component of the main structure already damaged, yielded, and that's why they reduced the integrity of the structure. And the best point is up to this point, which is the valid results. And unfortunately, this structure did not pass the regulation. There was a good verification between the experimental and the numerical result, but according to we should receive 11 kilojoule, but we are less than 1 kilojoule. So, but we decided to refine the model. So this is the new model that our group designed for this bus structure. And in the new design, it is all with the steel and all welded. It is basically we didn't change a little, changed too much the mass, but basically we have all the steel, again non-linear material behavior, and also remain the chassis as it was in the previous model. In this sense, we have the energy, total energy of 11 and 112 kilojoule, which the minimum energy should be 25. So let's see if it has a possibility to pass the regulation. Regarding the residual space, it was a little bit reviewed, and right now we have 20 millimeter distance between the residual space and the top chassis surface, which is related to the place of the seats with 20 millimeter. And we consider right now 2 points. One point in the bottom side with this altitude, and another point at the top with this altitude. And these 2 points should not have the displacement greater than these 2 values, which is calculated from the standard. And first, we applied the load on the door side on the center of mass. So we calculated the mass center of the total structure and just put the load in the corresponding angle. This is the force displacement results, and this is the minimum energy, 25 kilojoule. Unfortunately, this one has the possibility to pass the regulation since the energy is 26.4. What about the application of the load on the other side, on the window side? So imagine if we have the rollover test on the other side, and we apply the same load, the same condition on the window side. We got the force displacement, and here we have the energy of 25.7, which is greater than the minimum energy. So we can say that this new structure can pass from window side and from the door side. And this is the one BCSS distribution on the 2 different load applications. This is the smooth, and in some places for sure we have yield. The material has already yielded. But we are looking forward to the real test. We have already ordered this structure from the company to give us for the real experimental test. And also it is required to make a comparison between the numerical and the experimental analysis. So this work is still ongoing. Thank you.
Any questions? No questions?
Yeah, because it's not relevant to the.
It's a bit relevant because of safety.
Yeah, it's safety of the bus.
Yeah. Thank you.
Thank you.
Again.